So for this particular question, they are referencing vectors. A vector can be thought of as starting at the origin and using this information to make a line segment. So I'm going to go from 0, 0 to negative 3, comma 4. I can connect these, and my arrow will show what direction my vector should be going in. So that means that my shape, whatever it is, should move following that arrow. So now as you can see over here, I have my pre-image in green, my image in pink, and what I'm going to do is I'm going to line up the vector at each one of the points, and you'll see how they always line up from point to point. I'm going to do one for each one of them. Noticing that whenever you do this, it should make what looks like a prism of some sort. Should look like a three-dimensional object. So if you notice, the three yellow lines all are parallel. They're all heading in the same direction using that negative 3, comma 4. So the correct answer for this one should have been, they are parallel and congruent because they're all exactly the same. They're all going to have the same distance because they all exactly match this line. All right, let's take a look at this one. So here they're asking us which transformation will map figure H onto H prime. So we're going from here to here, right? So first they're asking if it's a reflection over the y-axis. That means that this guy would have flipped over here. That's definitely not correct. They're asking about a vertical translation of 10 units. Vertical translation. Now, whenever you see this phrase, this means up or down. It could be either one. So I'm going to do a test point, and I'm just going to see. So I'm going to start here, and I'm going to finish down here at this blue dot. Let's see how many are in between here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is technically a vertical translation of 10 units. It would not be 15 because this blue point would be 5 further down. And it could not be a reflection across the x-axis simply because if I look at this, and I'll do this part in pink, notice I have 2 units here, but I have 3 units here. So that means x is not acting as my mirror. All right, let's take a look at the last one. So here they said that I have triangle QRS, and it's being translated to Q prime, R prime, S prime, and they gave us 2 of the sides and an angle, right? So they gave us a couple of these theorems, but it's important to know what these theorems are. So SSS means side, side, side. That means that we have all 3 sides and they match exactly. So I have my pre-image here in this blue color, and it matches exactly with the green. If I have all 3 sides, that is side, side, side. That's how I prove these triangles are exactly the same. Now, if instead I have a side, one angle, and another side in that exact order, I would do side, angle, side. The reason is, if these 2 sides are the same and the angle in between them is exactly the same, we have no other choice but for this particular side to be an exact number. It's got to be exactly the same. Now, we have another one, angle, side, angle. That means angle, my first angle matches, my side matches, and a second angle that's immediately after the side matches. Same thing, because we have this amount of information, we can infer that these triangles are exactly the same. Now, these 3 theories up here all apply to every single kind of triangle. Doesn't matter which kind it is. However, this last one, hypotenuse leg, only applies to right triangles. What this means is, if I have my hypotenuse that is exactly the same, as well as either one of the legs, it doesn't matter which one, that means that these 2 triangles are exactly equivalent. So let's take a look at this problem. So here I have my triangle QRS. It has a right angle at Q and RS, excuse me, hold on one second. Let me draw this out. So we know Q and Q prime are both 90 degrees. We know that RS is 10 units, same as R prime, S prime. And we also know that my QS is 5 units. So, because this is a special triangle, a right triangle, and I know the hypotenuse and a leg, my correct answer is the HL theorem.